In this video, we will look at how the survival of living things is affected by the physical conditions of their environment. Specifically, we will focus on the sea life at the rocky seashore. Living things have basic needs in order to survive, such as water and food. Indeed, all life forms are part of the food chain in some way, so they need shelter to hide from predators, but also to protect themselves from harmful environmental conditions, such as being too hot, or too cold, or too dry, or too wet. Living things have structural features and adaptations that help them to survive in their environment. These barnacles, for example, are covered in a hard shell that holds in the water and protects them from the sun when the tide goes out. As environments go, the seashore is a pretty tough place for life. For several hours of the day it's underwater, while other parts of the day it's exposed to the air. In winter the foreshore can be close to freezing, while in summer baking hot. The life forms that live here need to cope with these extremes, which are caused by the changing tides. As such, the seashore is often called the intertidal zone. The area below the low tide that is always submerged is called the subtidal zone, while the area just above the highest high tide mark is called the splash zone, because it can still get a bit wet if waves splash this area, but it's usually dry. Rocky intertidal zones can be made up from soft rocks or hard rocks. Soft rocks are sedimentary, such as sandstone or mudstone, and these can be eroded by wave action. These rocks produce a broad platform with a sudden drop-off at the seaward side, and cliffs at the landward side. Hard rocks, such as granite or basalt, are more difficult for waves to erode, so they often have rubble, large boulders, and the foreshore is steep or just a cliff, with little in the way of platforms. Sedimentary rocks have layers, and often some layers are softer than others, so waves can erode these soft areas, leaving crevices or depressions in the rock where pools can form. Some sedimentary platforms can have large boulders fossilised within them, and these can also be eroded out, leaving a hole where the rock once was, again producing a rock pool. When you think about it, a rock pool is actually a permanent water body, submerged when the tide is in and full of water when the tide is out. A rock pool can remain stagnant for 6 hours or more without any fresh seawater to replenish it, so the life forms in there need to be able to cope with low oxygen levels, above average temperatures and bright sunlight. There are 3 types of life forms that occupy rock pools: casual users, those seeking refuge, and consistent rock pool inhabitants. The casual rock pool user can be found both in the rock pool or anywhere else in the intertidal zone. They can happily survive in and out of a rock pool. Often these animals have a shell that they can close when the tide is out and they are exposed to the air, so mussels, oysters and barnacles. Or the waratah anemone that can pull in its tentacles and remain dormant for a few hours. Animals seeking refuge in rock pools are usually found in the subtidal zone, but wander around the intertidal zone when the tide is in. They can't survive in the open air, so they seek refuge in rock pools when the tide is out. These include some snails, hermit crabs, and sea stars such as these 8-armed sea stars. Certain types of seaweed can be considered refugees as well. This white coralline algae isn't growing on the rocks around the pool, but is common in the pool. Consistent rock pool inhabitants have evolved to make the most of this habitat and prefer the shelter of rock pools even when the tide is in. The algae Neptune's necklace can easily be washed off rocks by wave action, so on a rock platform it is often found in rock pools where it is protected. Sea anemones are often found in rock pools as well, such as this southern anemone. The delicate looking rock pool shrimp is well protected in the relative calmness of the rock pool. Boulder fields are a type of rocky foreshore where a range of disconnected rocks sit usually on a sand or a platform and provide 3 different habitats for life: the top surface of the boulder, the underside surface of the boulder, and the land directly underneath the boulder. The top surface is the most exposed, so it experiences pounding waves and bright sunlight. The life forms here need to be able to cope with these conditions. This surface often holds a thin film of algae that provides food for grazing animals. These animals have the ability to stick to rocks and withstand the exposed conditions. Examples include mollusks such as this ribtop snail and the chiton. The underside surface is in the shade and out of sight from predators such as seabirds, so animals such as sea stars occupy this habitat. The land under the boulder can provide shelter for animals such as crabs. This crab is called the New Zealand half crab or porcelain crab, so called because if you try to pick one up you'll find that they are very fragile and they often lose a claw. They were accidentally introduced to Tasmania from New Zealand in the 1900s. Notice that they are very flat, which enables them to hide under the rocks. If we look across the intertidal zone, from just above the subtidal zone up to the splash zone, we find that there is a general pattern of distribution of living things. There tends to be more seaweed and mussels near the low tide mark. As we progress up the intertidal zone, at low tide it becomes drier, so the animals and algae that can withstand the sun and dryness become more common. When we get to the splash zone, the last animal we find is the banded periwinkle. Dormant for most of the time, they only emerge to feed on lichen and algae when the rocks are wet by rain or splashing waves. Mollusks are usually the most common animals seen on the rocky foreshore, especially snails, otherwise known as gastropods. Many snails are herbivorous, such as this periwinkle, also known as a warana. There are carnivorous snails as well, and many of these belong to a group called whelks. Some whelks eat other mollusks. They drill a hole in the shell of their prey using a sharp tongue called a radula, as well as emitting a chemical that dissolves the shell. These predators can find their prey by smell using their siphon. This tube sticks out in front of the snail and moves from side to side, smelling the water. Watch how it draws in the dye that is placed in front of it in the water, then it's expelled out the side of the body. Predatory snails have a special groove in their shell that the siphon sticks out of, so it's easy to identify if a snail is carnivorous by looking for this groove. Many gastropods have a type of door that they close to protect themselves. It's called an operculum, and here you can see it on this whelk. Herbivorous snails have a very circular operculum, and you can often find these washed up on the beach. As the intertidal zone is a boundary between the sea and the land, with waves washing over it, small particles of organic matter floating in the sea, especially plankton, accumulate in this area. This presents an opportunity for filter-feeding animals to collect these particles to eat. On rocky foreshores we find animals that permanently attach to the rocks. This is called being sessile. Mussels, barnacles, oysters, and sea squirts are such animals. When the tide is high, they open their shells, or in the case of the sea squirt their siphon, and draw water into their bodies to filter the microscopic particles from the sea. When the tide is out, they can close their shell, or siphon, lower their heart rate and survive on the water held inside. Algae, or seaweed, varies in type across the intertidal zone and can be classified into three main groups: encrusting, folios, and canopy. Encrusting algae spread over a rocky surface and a flat or low line. They are able to withstand the dry conditions of the upper intertidal zone, so they are the most common algae here. At the extreme driest parts of the intertidal zone, you will sometimes find lichen clinging to rocks. This is a symbiotic organism that is part algae and part fungus. Foliose algae look like plants, as the word foliose means leaf-like. They are branching and upright and dominate the lower intertidal area where they experience a lot of wave energy. Two main types of foliose algae exist: soft and flexible algae that bend with the waves, such as sea lettuce, or tough and wiry algae that are so tough as to withstand the wave action, such as this kelp. Canopy algae look like mini trees, standing up and draped over the rocks at the lowest part of the intertidal zone. This is usually made up of larger varieties of the tough leather-like algae kelp. That concludes our brief summary of the rocky intertidal zone. We have a companion video to this one about the sandy intertidal zone, which is worth comparing to the rocky area.